Have you ever wondered how a car moves? The engine creates power, but it needs help getting that power to the wheels. This is where the transmission comes in. A transmission is a gearbox. It sits between the engine and the wheels. Its main job is to control the amount of power the engine sends. Think of it like the gears on a bicycle. When you go uphill, you use a low gear. This makes pedaling easier, but you don't go very fast. When you are on a flat road, you use a high gear. Pedaling is harder, but you can go much faster. A car's transmission does the exact same thing for the engine. A car's engine has a sweet spot. This is a specific range of revolutions per minute, or RPM, where it runs most efficiently. If the engine's RPM is too low, it can stall. If it's too high, it can waste fuel and damage itself. The transmission's job is to keep the engine in this happy RPM range. It does this by changing gear ratios. A low gear provides more torque, which is the twisting force needed to get the car moving from a stop. A high gear provides less torque, but allows the car to reach higher speeds without overworking the engine. It's a critical component for both performance and fuel economy. Without a transmission, a car would be almost useless. Imagine trying to start moving in a very high gear. The engine would struggle immensely and likely shut off. It wouldn't have enough force to turn the wheels. Now imagine trying to drive on the highway stuck in first gear. The engine would be screaming at its maximum RPM, burning a lot of fuel and wearing out very quickly, all while the car moves at a crawl. The transmission gives the driver, or the car's computer, the flexibility to choose the right gear for the right situation, making driving smooth and efficient. So, the transmission is a power manager. It takes the single high-speed output from the engine and converts it into various speeds and torque levels for the wheels. It allows a heavy vehicle to start moving from a complete standstill. It also allows that same vehicle to cruise at high speeds on the motorway, while keeping the engine calm and happy. Whether you are driving a manual or an automatic, the fundamental purpose of the transmission remains the same: to transmit power from the engine to the wheels in the most effective way possible for any given driving condition. The story of the transmission begins with the very first cars. Early automobiles were simple machines. The 1886 Benz Patent motor wagon, often called the first car, didn't have a multi-speed transmission at all. It had a single gear. This worked, but it was very limited. To go faster, the engine had to spin faster. This was not efficient or practical. Inventors quickly realized that for cars to be useful, they needed a way to change gears. This led to the creation of the first manual transmissions, which gave drivers more control over the vehicle's speed and power. The first multi-speed transmissions were quite basic. A company called Panhard et Levasseur is credited with developing a 3-speed manual transmission in 1894. This was a major breakthrough. These early transmissions were often unsynchronized. This meant the driver had to be very skilled. To shift gears without a horrible grinding noise, the driver had to double clutch. This involved matching the engine speed to the speed of the transmission gears manually. It was a difficult process that required a lot of practice to master. Driving was much more of a physical and mental task than it is today. As cars became more common, the demand for an easier driving experience grew. This pushed engineers to develop the automatic transmission. In the 1940s, General Motors introduced the Hydromatic. This was the first mass-produced fully automatic transmission. It used a fluid coupling instead of a clutch to connect the engine to the transmission. It also shifted gears by itself using hydraulic controls. This was a revolutionary invention. It made driving accessible to a much wider audience of people who did not want to deal with the complexities of a manual gearbox. Suddenly, driving in stop-and-go city traffic became far less of a chore. Today, transmissions are more advanced than ever. Early manual cars might have had only 2 or 3 speeds. Modern street cars, both manual and automatic, commonly have 6, 7, or even 8 speeds. Some automatic transmissions now have 9 or 10 speeds. More gears allow the engine to stay in its most efficient RPM range more of the time. This improves fuel economy and provides smoother acceleration. We also have continuously variable transmissions, or CVTs. These don't have fixed gears at all. Instead, they use a system of belts and pulleys to provide an infinite number of gear ratios for ultimate efficiency. To understand how a transmission works, we need to look at its main parts. In a manual transmission, one of the most important components is the clutch. The clutch is the connection between the engine and the transmission. When you press the clutch pedal, you are disconnecting the engine's power from the gearbox. This allows you to shift gears smoothly. Without the clutch, Changing gears would be a noisy, grinding affair that would quickly destroy the transmission's internal parts. The clutch consists of a pressure plate and a disc that engages with the engine's flywheel. Inside the gearbox itself, you will find a collection of gears of different sizes. These gears are mounted on shafts. The input shaft receives power from the engine via the clutch. The output shaft sends power to the wheels. The magic happens on the lay shaft or counter shaft. The input shaft turns the lay shaft, which has several gears fixed to it. These gears are always meshed with another set of gears on the output shaft. However, the gears on the output shaft can spin freely until they are locked into place by the driver using the gear selector or shifter. When you move the gear shifter in your car, you are controlling a set of selector forks. These forks slide a component called a dog clutch, or synchronizer ring, along the output shaft. The synchronizer is the key to modern, smooth-shifting manual transmissions. Its job is to match the speed of the gear you are selecting with the speed of the output shaft before they engage. This eliminates the grinding noise that was common in early, unsynchronized transmissions. Once the speeds are matched, the dog clutch locks the gear to the shaft, and power flows through that specific gear set to the wheels. In an automatic transmission, things are a bit different but based on similar principles. Instead of a manual clutch, it uses a torque converter. A torque converter is a type of fluid coupling that uses transmission fluid to transfer power from the engine. It allows the engine to keep running even when the car is stopped. Instead of manual gear sets, it uses a planetary gear system. This is a compact set of gears that can create different gear ratios by locking and unlocking different parts of the set using a series of clutches and brake bands which are controlled by the car's computer. The transmission in your daily driver is designed for a very different life than one in a race car. Street car transmissions, whether automatic or manual, prioritize smoothness, fuel efficiency, and longevity. They need to last for hundreds of thousands of miles with minimal maintenance. They are designed to handle stop-and-go traffic, gentle cruising, and the occasional burst of acceleration. The shifts are engineered to be almost unnoticeable to the driver and passengers. Comfort and reliability are the main goals for the engineers who design these gearboxes for the mass market. Now let's look at a NASCAR race car. These cars still use a traditional 4-speed manual transmission with an H-pattern shifter, similar to a classic muscle car. Durability is absolutely critical. A NASCAR transmission must withstand hours of abuse at maximum power. The gears are dog box style, which means they do not have synchronizers. This allows for very fast, aggressive shifts, but they are harsh and noisy. The driver must match revs to shift smoothly, but the components are built to take a beating. The focus here is on pure strength and reliability under extreme racing conditions, not on driver comfort. Formula One represents the pinnacle of transmission technology. An F1 car uses a highly advanced 8-speed seamless shift semi-automatic paddle shift gearbox. The driver shifts gears using paddles on the back of the steering wheel. The shifts are incredibly fast, taking only a few milliseconds. There is virtually no interruption in power delivery to the wheels, which is why they are called seamless. These transmissions are extremely lightweight, made from materials like carbon fiber and titanium. However, they have a very short lifespan. An F1 gearbox is designed to last only a few race weekends before being rebuilt or replaced, prioritizing ultimate performance over long-term durability. In summary, the differences are all about purpose. A street car needs a reliable, smooth, and efficient transmission for everyday life. A NASCAR needs an incredibly tough and simple gearbox that can survive a brutal race. A Formula One car needs the fastest shifting, lightest, and most technologically advanced transmission possible, where cost and longevity are secondary to lap time. Each transmission is a perfect example of engineering a solution for a specific problem. They are all transmissions, but they are tailored for completely different worlds, from the morning commute to the final lap of a championship race.